Okay, so let's start with the last question in graphing, which is about the graphing exponential function. So directly, how to solve this function? First of all, I'll start by finding the domain. This is not a normal exponential function. This is exponential function with a power which is rational, minus 2 over x. Okay, so this is composition actually of two functions. So in here, I can know, or you already know that the domain for the exponential function, if it's e to the power x, it's from minus infinity to infinity. But because in here we have rational function, so we have 0 for the denominator, which is x equal to 0. So it will be r minus the 0 of the denominator, which is 0. Okay, now let's find what will happen at that 0 actually. So let's see limit when x tends to 0 from the right. Okay, because we already know that what will happen if we have, for example, normal rational function with polynomial in the numerator and polynomial in the denominator. We know what will happen if we have e to the power x, but what will happen if we have composition, exponential with rational together? Okay, so let's see, limit x tend to 0 from the right. Okay, this is going to be equal to e to the power minus 2, or for minus 2 over x. Okay, so the direct substitution, it will give me minus 2 over 0, which is positive, negative, infinity does not exist. So in here, let's see how to find this. Now, minus 2 over 0, we need to test the sign. Now, for the x, the 0 of the x is 0. Sorry for that. Okay, okay. So the 0 of x is 0. So from the right of the x is positive and the left it will be negative. So in here, this is going to be equal to the one we need to find limit x tend to 0 from the right and x tend to 0 from the left of e to the 1 minus 2 over x. Okay. Now this is going to be minus 2 over, now since we are talking about value to the right of the 0, okay, so that means it will be positive infinity, okay, or positive value from the right. So minus 2 over a positive value, it will be, because we have negative, so the answer for 2 over x, it will be positive infinity. But since we have negative over here, so it will be e to the power minus infinity, because we have minus 2. Now, if you have 2 over infinity or 2 over 0 from the right, it will be positive infinity. But because you have negative, it will be negative infinity. Okay, so e to the power minus infinity, this is equal to 1 over e to the power infinity, which is 1 over infinity, which is equal to 0. Okay, so from the right of the 0, I have point, which is 0. Okay, so in here, from the left, it will be in here e to the power minus infinity, okay, because from the left of the 0 it will be negative, so minus infinity. So minus infinity, this is e to the power infinity, which is equal to infinity. Okay, so from the left of the 0 I will have something like the vertical asymptote, and from the right I have normal point or 0. Okay, so let's see how we can find this. So starting with solving the question as usual, which is finding f prime. So f prime, it will be the same exponential function, minus 2 over x multiplied by the derivative of the exponent, which is minus the constant, so plus 2, multiplied by the derivative of the denominator, which is 1 over the denominator square. Okay, so this is 2 e to the power minus 2 over x squared. Let's make this equal to 0. The zeros from the numerator, e to the power minus 2 over x equals 0, and that will be rejected because we have to take ln of 0. So it's undefined. Now the undefined values, it will be the denominator, x squared equals 0, and that will give me x equals 0. So in here directly x equals 0, so it will be rejected because it's excluded from our domain. So I grab the number line, I'll put the 0, but I will not count it as a critical number. So this is the 0. Okay, let's test the sign. So in here, this is rejected. Be careful. Okay. So let's test the sign. So from the right of the zero, we have to substitute in the derivative. That's it. So let's see what values we can get. So directly to the calculator, I'll write my function. So this is 2 alpha e to the power, here we have rational, minus 2 over x, right, over x squared alpha x squared. Okay, so let's calculate at 5. Okay, 5 is fine, so positive. Let's calculate at value less than 0. So this is minus 1. So positive, positive. Okay, so over here we have positive, positive. So positive. So increasing, increasing. So the increasing interval. So the function is increasing from minus infinity to 0 union with 0 to infinity. Okay, no critical points. Okay, so let's go ahead and find the second derivative. So f double prime, this is equal to what? The denominator, x squared, multiplied by the derivative of the numerator. The derivative of the numerator is 2e to the power minus 2 over x, multiplied by the derivative of the exponent, which is 2 over x squared. Okay, so this is the denominator multiplied by the derivative of the numerator. Okay, this is okay, this is okay. So the denominator multiplied by the derivative of the numerator minus the numerator 2e to the power minus 2 over x multiplied by the derivative of the denominator, which is 2x, which is 2x over the denominator square, x to the power. So now let's simplify it a little bit. So it will be over here. We can eliminate the x square with x square. So I will have from here 2 times 2, which is 4, e to the power minus 2 over x, minus, and here we have 2 multiplied by 2, which is 4, x e to the power minus 2 over x. Okay, so over x to the power 4. So I can take 4 e to the power minus 2 over x as a base common factor. Okay, that will leave me with 1 from here minus x from the second one over x to the power 4. Let's make this equal to 0. From the numerator, zeros, I will have e to the power minus 2 over x equals 0. That will be rejected. So the second one, 1 minus x equals 0. And that will give me x equal 1. Okay, and also from the denominator, the undefined values, I will have x to the power 4 equals 0, so that will give me x equal 0. This is going to be rejected, this is accepted. Now I have only one value, that could be inflection point. Now for this, it's rejected, but I will take it on the number line. So let's take this, the number line. Okay, this is for the second derivative, this is the 0, and this is the 1. Okay, so let's substitute in the second derivative and see what signs we will get. So in here, this is okay. I think I can take this to be easier. So this is 4. It's multiplied by okay, multiplied by 1 minus x, okay, then over x to the power 4. Okay, so in here, let's calculate it at value less than 0. Okay, let's say it's minus 1. So this is positive. What about value greater than 0 and less than 1? So 0.5. This is positive as well. So positive, positive. Until now, yes, positive, positive. So let's say if we have 2 negative, so positive, positive, negative. So here we have positive, positive, and negative. So this is concave up, concave up, concave down. Okay, so now I know that I have concave up, concave down also after the one, so it's concave. Let me just put the charger. So whatever. So in here I can write concave up. It will be from minus infinity to 0 union with 0 to 1, and concave down from